Today we are going to discuss competitive inhibition in this video. So first of all, we need to know the basic concepts of enzyme substrate reaction, which is the enzyme reacts with substrate to form enzyme substrate complex, which eventually leads to the formation of product which is measurable. Now in this reaction, the enzyme which initially reacts with substrate is released free so that it can interact with other substrate in the reaction to carry out the reaction in forward direction. Now in competitive inhibition, what happens is the inhibitor is a structural analog of substrate, so it competes with each other to bind to the active site of the enzyme. Suppose this is the active site of the enzyme. Normally the substrate binds over here, and if inhibitor, which is supposed to be the structural analog of substrate, binds to the active site, which happens here, no product formation is observed. Now we need to note what is the effect of this inhibition on Km and Vmax. So what is Km? This is basically the substrate affinity, or how much substrate is required to reach half Vmax. And what is Vmax? This is maximum velocity. So we need to note the changes in these two factors. So in case of competitive inhibition, the Vmax remains constant because as we increase the substrate, the inhibition is reversed, or the inhibitor is removed from the active site and substrate binds in place of the inhibitor. So the Vmax remains constant, but the Km increases in this case, because we can see that if we increase the substrate amount, the inhibition is reversed. So more amount of substrate is required to reach to the Vmax. So the Km in this case increases. Now coming to the changes in slope, we can see in this equation, which is the basic Michaelis-Menten equation, which states that V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. Now if we reverse this equation, which happens in case of Line-Weaver-Burg plot or the LB plot, the equation becomes this. The slope of the equation is this one. Now we have already mentioned here that Km increases in this case. So the increase in Km occurs by the factor 1 plus I by Ki. So the slope becomes Km multiplication of this factor and plus 1 by Vmax. So the slope is now this one. So this is the basic change between the Michaelis-Menten equation or the LB plot equation and after the inhibition. So if we go to the plot, we can see this dashed line is without inhibition and this solid line is with inhibition. So as we already know that the Vmax remains constant, which is denoted by this, and the Km here increases, so 1 by Km decreases in this case. So coming to the example of this inhibition, so if a person accidentally has methanol, it leads to formation of formaldehyde, which is harmful for our body. So if it is substituted by ethanol, it leads to the formation of acetaldehyde. So methanol and ethanol are structural analogs. This is the normal substrate and methanol is the inhibitor. So this is a classic example of competitive inhibition. So to summarize, we can say that in this inhibition, the inhibitor is the structural analog of substrate. The Km increases in this case and Vmax remains constant, and the slope of the reaction is this. So if you like this video, please don't forget to like and subscribe. Thank you.